Thank you, Prof. So every year here in the US, we generate hundreds of millions of tons of coal ash, and we've long viewed this industrial byproduct as waste. But what if I told you that buried within this waste are hidden stockpiles of critical raw materials and rare earth elements? The very same materials we are scrambling to secure for our clean energy transition, military infrastructure, and advanced manufacturing. So today I want to really focus on reframing the narrative around this industrial byproduct to explore how, when we leverage these strategic raw materials, it could help us be a national asset where we can really extract the critical raw materials that we need to help us advance so that's our resilient supply chain, and to reduce our reliance on foreign sources for critical raw materials. And more important, apart from sourcing these raw materials for our industrial needs, long-held industrial or environmental implications of coal ash leachates on the environment are really avoided when we source these critical raw materials from coal ash. So let's set the record straight here. Coal ash has real implications in our supply chain, and we have the chance to really, from here in the US, we have been able to estimate some median concentrations of around 481 milligrams per kilogram of rare earth elements in US coal ash. And we have the potential to recover around 9,000 tons of this rare earth elements from this coal ash that we have been estimated. And so from this criticality matrix, we have been able to estimate significant concentrations of these rare earth elements. So, for example, the dysprosium, gallium, we have also been able to estimate, for example, neodymium, terbium, and all these muons that you're seeing in the plot. We've been able to estimate some significant concentrations from US coal ash. And so rare earth elements are not really rare. And coal ash is ubiquitous here in this country. So, for example, we have been able to identify in every single state here in the US coal ash disposal sites. And one deeply concerned aspect of this disposal site are the evidence of coal ash leachates that have been formed over the years. And we have been able to identify significant major and trace constituents in these coal ash leachates. For example, we found concentrations of arsenic, which is carcinogenic. We found cadmium, we found lead, we found mercury. And these all have health and environmental implications of human health. And we wanted to understand from a life cycle assessment perspective, when we take this coal ash from the landfill, we process the coal ash to extract the critical raw materials, the environmental implications that we are avoiding when we extract these critical raw materials. We wanted to understand this, and from the nationwide leachate data set that we measured and estimated, we found this environmental consideration that we really have to model when we really want to focus on extracting these critical raw materials for our industrial byproducts. And talking about environmental implications, when we take this coal ash from the landfill, originally coal ash has been deposited at the landfill, and we have found evidence of massive amount of leachate that have been formed already at legacy coal ash disposal sites. And so when we take this coal ash, we process the coal ash to extract the critical raw materials that we need. We are really avoiding the land use impact. We are avoiding the leachate formation at the landfill, and we are also avoiding the greenhouse gases that can be formed when we construct this landfill for the storage of this coal ash disposal sites. And more important, we estimated the environmental implications of this leachate formation at the landfill from life cycle assessment perspective, and we found that this arsenic, the cadmium, the lead, they are really contributing significant amount of human health implications. So we found, for example, per ton of coal ash leachate we analyzed, around 8.5% of human health carcinogenic impact per person per year here in the US. This is significant, and so when we focus on extracting these critical raw materials from long-term coal ash disposal sites, we are really avoiding all these environmental implications in human health, and it's something very important that we need to consider. So we estimate, I hope you can see. Okay, so we estimate this net environmental benefit of extracting these critical raw materials from the coal ash leachate by estimating the raw environmental implication of the baseline scenario of really, for example, processing this critical raw material from the coal ash landfills, and then also the avoided impacts that can happen when we leave this coal ash at the landfill. So we estimate these individual components, and from there we are able to quantify the benefits of utilizing coal ash as a source of feedstock for the critical raw material extraction. Not only about the source reduction environmental component that we really need to also consider, we have to also consider the fact that these coal ash feedstocks are low-grade feedstocks. The coal ash, the concentrations of these critical raw materials are not so much. And so we consume high amount of energy, the resource consumption goes high, and this extrapolates to the overall life cycle impact, and something that we really have to consider as compared to higher grade conventional feedstocks that we normally process for these critical raw materials. And so considering the environmental implications of coal ash, extracted critical raw material from the coal ash feedstocks, and also the techno-economics of making sure that we are extracting this critical raw material, we are scaling this to achieve some profits from our industrial process. It's important for us to consider on both ends the environmental implications and also the profit that we can obtain from critical raw material extraction from low-grade feedstocks. And there are real competition because not only the mineral processing industry that really are going to be extracting critical raw material from fly ash or the coal ash that has been deposited at the landfills. We have found that here in the US, the construction sector, the cement and the concrete sector, they are harvesting significant amount of these millions of tons of this coal ash for either cement manufacturing or as a replacement of cement in concrete. And for the past 30 years, this consumption of this coal ash from the landfill has been accelerating. But nonetheless, we do have a reasonable estimate of around 2 billion tons of this coal ash that can support both industry, the mineral processing and the construction sector, for a reasonable number of years. There are real challenges that these companies can face in the course of extracting these critical raw materials from these coal-derived landfills. Most companies, nobody set up a company for charity. It's all about profit. And extracting these critical raw materials from low-grade feedstocks is really challenging without our policy support. And we found that, for example, because these companies cannot really, at the moment, focus on extracting these critical raw materials just as a single business model. There has to be some sort of hybrid business model that can help these companies really make profit from extracting these critical raw materials from such a low-grade feedstocks. And one key aspect could be, for example, mining more coal, combusting the coal to generate energy, feeding the energy to our grid. And also, when we combust coal, we release enormous amount of greenhouse gases. That is CO2. And we already have policy in place. For example, the 45Q tax credit, the companies can really capture the CO2 that comes out from the coal combustion power plant. And also, they are getting some tax credit from that standpoint. And the coal ash that are generated from the power plant, we can really process this coal ash and then extract these critical raw materials from this coal ash that we are producing from coal combustion. And also, processing of this critical raw materials from this coal ash we are generating, we also qualify for the 45X production tax credit. And so, technically, it's really possible for us to extract these critical raw materials from low-grade feedstocks from the coal ash. But the current economic constraints and the current market condition introduces some sort of uncertainties in this field in respect to extracting these critical raw materials from these coal ash waste streams. And for the past couple of years now, we have seen the critical raw materials commodity sector trading at the lower end of the pricing in this sector. And so combining that with extraordinarily high capital expenditure will really discourage most companies from really venturing into this sector of really extracting critical raw materials from low-grade feedstocks. And so policy implications and so policy support will be very key for this industry. And we believe that policy supports that are geared towards this sector to support emerging companies and startups should really be focused on, for example, rigorous policy analysis to really understand the fundamentals of this emerging industry, to be able to support these companies, to incentivize them to continue producing critical raw materials from low-grade feedstocks. And we do have a reasonable understanding that when we, for example, support these companies, increase the subsidies, supporting them with subsidies at the carbon capture end of this production scenario, companies are more encouraged to capture more CO2, which is more beneficial for the environment. And so we have real policy in place, we have real support in place that can really support companies to continue producing critical raw materials from these low-grade feedstocks. But another thing that we also have to consider is the fact that we do know right now that we can obtain critical raw materials from coal ash in this country, and we have identified significant concentrations of these critical raw materials from coal ash in this country. And we also do know that there are some environmental benefits of reducing these environmental implications that are carcinogenic, for example, the release of arsenic and cadmiums and lead and mercury from this leachate formation at the landfill. We take this coal ash, we process this coal ash, we extract the critical raw materials, we are avoiding these environmental implications. And more important is also the aspect that we need to consider regarding the high energy consumption and the high resource use due to the fact that we are extracting these critical raw materials from low-grade feedstocks. And the hope we have in recent times is regarding the new technologies that have been deployed to help scale the production of critical raw materials from low-grade feedstocks and coal combustion products. One of them is the new patent that have been filed by National Energy Lab, and we are anticipating that very soon we'll be able to deploy such technologies at scale to really extract these critical raw materials for our national needs. But as I mentioned, it's going to be really challenging at the current market conditions and the current economic scenario for companies to really focus on a single business model of only extracting critical raw materials from coal-derived waste streams, because it's all about profit. And without policy support, without incentives from the government, it's going to be challenging for companies to really focus on such single business model. And one key aspect could be to combine hybrid business model of combining coal combustion, extracting the energy from coal combustion, feeding the energy to the grid, and also capturing the CO2 that are coming from coal combustion, processing the coal to extract the critical raw materials, and applying for both the 45Q tax credit and also the 45X tax production credit. And so we believe that here in the US, we have real opportunities to really obtain critical raw materials from our coal combustion products. And that is what we believe that we can really focus on both in the long and in the short term. Yeah, thank you.
All right. Thank you, Philip.